Hello everyone, this is Nokukanya Zikali presenting compressibility factor by group 72. The gas compressibility factor tells us how much the real gas deviates from the ideal gas at a given pressure and temperature. It is simply defined as the ratio of the molar volume of a gas to the molar volume of an ideal gas at the same temperature and pressure. If compressibility factor equals 1, then the particular gas is said to behave like an ideal gas. If compressibility factor is less than 1, then the particular gas does not behave like an ideal gas, and that is because it has force of attraction. If compressibility factor is greater than 1, it is an ideal gas because it has finite volume of molecules. The compressibility factor for specific gases can be read from generalized compressibility charts that plot compressibility factor as a function of pressure at a constant temperature. The compressibility factor value generally increases with pressure and decreases with temperature. Gases behave as an ideal gas regardless of temperature when reduced pressure is much lesser than 1. From question 1.6 in the template, which asked what observation can you make about the variable reduced pressure as the variable z approaches 1. And from the graph, we can see that as z increases and approaches 1, the value of reduced pressure increases significantly, and at this point, the gas also approaches to behave as an ideal gas. From what I said, we can tell that compressibility factor is directly proportional to pressure. From question 2.6, which asked what assumption can be made about the compressibility factor when the pressure is small relative to critical pressure. Our answer was that for small values of P relative to critical pressure, the value of compressibility factor will also be small. This is because compressibility factor is directly proportional to pressure. Thus, when pressure is small relative to critical pressure, compressibility factors will also be small. We define this from the formula. Compressibility factor Z is equal to pressure times specific volume divided by gas constant times temperature. Thank you for listening to the presentation.